The next part of the nuclear energy is nuclear fusion. Fusion, as the word suggests, that means to combine. Now, the nuclear fusion is a process in which the lighter nucleus are combined in order to form the heavy nucleus. In this process, the tremendous amount of energy is generated. Now, when we talk about lighter nucleus or lighter elements, so we are talking about the hydrogen. When hydrogen are combined, these hydrogen basically has the same charge. So when they are made to combine, then they repel each other. Now, how we are going to combine them? These are combined at an extremely high pressure and at an extremely high temperature. In this extremely high temperature and pressure, the nuclear fission is going to take place. So, for the nuclear fission to carry out, the high temperature and the pressure becomes the basic necessity. Now, you can see from the reaction, this is called the nuclear fusion reaction. In this reaction, two deuterium hydrogen atoms are combined together to release helium, neutron and tremendous amount of energy. This amount of energy is released in the form of heat and light energy. Now, the nuclear fusion reaction is a reaction which has various advantages as well as various disadvantages. There is a major difference between a nuclear fusion and a nuclear fission. Now, let's talk about first the difference between the two. In the nuclear fusion reaction, the lighter elements are combined in order to form the heavier element. While in the nuclear fission reaction, the heavy nucleus is bombarded by the neutron in order to split up into smaller or lighter nucleus. So, the process is just the opposite. Second is the case when the nuclear fusion reaction, it produces tremendous amount of energy and this amount of energy is uncontrollable. While in the case of nuclear fission reaction, this tremendous amount of energy is controlled by the boron rods. The third difference is that the product produced in the nuclear fusion reaction is not radioactive. That is, it is harmless. While the products produced in the nuclear fission reaction is radioactive and is very harmful. Apart from it, the nuclear fusion reaction always require an extremely high temperature and high pressure to initiate the reaction, while the nuclear fission reaction does not rely on these requirements. Now, this nuclear fusion reaction is used as a hydrogen bomb. The hydrogen bomb is basically carried out on the principle of thermonuclear reaction. This thermonuclear is a word in which the nuclear fusion takes place at an extremely high temperature. When the nuclear fusion takes place at an extremely high temperature, then that is called thermonuclear process. Now, the hydrogen bomb always takes place in an extremely high temperature and it is initiated with the help of atom bomb. That is, when the atom bomb is exploded, the amount of heat energy produced is very large, which initiates the hydrogen bomb, and the hydrogen bomb produces tremendous amount of energy in the form of heat. Second is the case when the sun also uses the nuclear fusion reaction. The sun is basically a huge mass of hydrogen gas. This nuclear fusion reaction inside the sun produces helium, neutrons and tremendous amount of energy. This energy is in the form of heat and light. This is the same energy which we get from the sun. That is, sun is the source of heat and light energy which comes from the nuclear fusion reaction. Now let's see the unit in which the nuclear energy is measured. Basically, the unit of energy is joule. This joule is represented by capital J. Now, in the case of nuclear energy, it is measured in electron volt. The electron volt is represented by small e and capital V. But electron volt is a smaller quantity. So, in order to measure the nuclear energy which is in bigger or larger form, we measure it by means of million electron volt. Capital M stands for million, E stands for electron and capital V stands for volt. Now, what is this electron volt? 1 electron volt is the amount of energy acquired by the electron with 1.6 into 10 raised to the power minus 19 coulomb of charge. with a potential difference of 1 volt. Now, if we have to find the energy, the formula for energy or the work done is given by Q into V. Q is the charge and V is the potential difference. Now, this energy is 1 electron volt. What is the charge in the case of 1 electron volt? It is 1.6 into 10 raised to the power minus 19 coulomb and the potential difference is 1 volt. So, on multiplying, you will get that 1 electron volt is equals to 1.6 into 10 raised to the power minus 19 joule. So, what is the value of 1 electron volt? It is 1.6 into 10 raised to the power minus 19 joule. But this is a very small quantity. We have to measure the nuclear energy in a bigger quantity. For that, we will require million electron volt. So, let's first see what is this million electron volt. 1 million electron volt is given by 1 electron volt into 1 million. So, in order for you to measure it in joule, you have to find out the value for it, that is 1.6 into 10 raised to the power minus 19 into 10 raised to the power 6, which is the unit to convert the million into the joule. So, in this case, 1 million electron volt is equals to 1.6 into 10 raised to the power minus 13 joule. So, this is how the nuclear energy is measured in 1 million electron volt. If we have to find out the conversion rate between million electron volt and the joule, so this is the conversion value, that is 1.6 into 10 raised to the power minus 13 joule.